This video we actually stop here. Okay, we identify all the four equations already. So what you're gonna do actually to determine the values of k, what is the sorry, the range of k. So in this case, for 8k in this case, k should be larger than 0, right? K should be larger than 0, straightforward. And then for this case, k should be larger than -4 because in other words this should be like, larger than 0, this should be larger than 0, this should be larger than 0, this should be larger than 0. Okay, that would be, cooler, like more easier to see. So in this case, it's a little more tricky. As I say, whatever thing that makes the numerator 0 will make the whole equation 0, right? So we don't care the 2 itself. Here, let's talk about 4 minus k. So in this case, k in this case should be smaller than 4. Yeah, okay, because I bring the k over here. Then now we have a little troublesome stuff over here. We have a quadratic, and then you know that because we already know that 4 minus k can be deduced over here, so we can initially cancel all these things. Yeah, but nonetheless I need to check. So hold on. Okay, so in order to save time, actually I just explain what I did over here. So I rearrange in terms of the highest order first, and then the lower order. So it's easier to set up the quadratic equation. You use the quadratic equation and then you solve, and then you will have either minus, negative, or 0.49. So as you know, k should be larger than 0. Okay, so we only pick 0.49. Okay, so we only pick 0.49. So in this case, in our quadratic case, k should be okay. In our case, we don't know whether should k be smaller or larger than 0.49, right? So you have to determine whether if you sub in 0.49, will this equation be larger than 0 or will it be smaller than 0? And therefore, let's try a value. Okay, let's try 0.39 in this case. So give me a moment. Similarly, I will use XL. So minus k is actually 0.39. Okay, I actually put in a number smaller than k. I mean smaller than the 0.49 limits. Okay, and then the minus away 32k. I didn't change anything, plus 16. So when I press enter, okay, I have a value. So for k that is smaller than 0.49, okay, so for k that is smaller than 0.49, we are considered stable. Okay, because if it's 0.49, you will sub it in, you are larger than 0, so it is safe. So so you may not believe what if it's larger than 0.49. So I have the same thing. C is negative. So so it is a pretty intuitive way to check. So you just sub in any value that is smaller or larger. If the outcome is the same as what you think, then it's okay. If it's not, then you just um write the opposite area. So from here you can see that k should be smaller than 0.49, and you have all this range. So what we do is to use the number line. So the whole one again. As you can see, I have already transport all my k's value over here, and then we are more ready to draw the number line. So the first thing when you do a number line is actually to sub in all the values. So we have 0, we have -4, we have 4, and we have a value of 0.49. Okay. So yeah, so the same thing for k should be larger than 0. So we have this value, we have this circle going into infinity, and then for k that is smaller than, k must be bigger than -4. I mean k must be bigger than 0 in this case. I mean here, k must be bigger than 0. So and then k must be bigger than -4. So it's also going to the infinity. And then k has to be smaller than 4. Yeah, okay, k have to be smaller than 4. So this is actually 4. Okay, so k must be smaller than 4. So therefore we are going into this. I hope you get what I mean, because if k is because k have to be smaller than 4, so k should be, this is because this is 3 3, 2, 1, so whatever k that is 3, whatever k that is 2 is safe. But if it's, let's say if k value is 5, then this does not satisfy this interval over here. So this is why so 4 must be, so k must be smaller than 4. So this is why whatever k value that is smaller than 4 is alright. So this is why we draw this line. So this line represents all values of k that is smaller than 4. Okay, and nonetheless, this blue and green line represents all values of k that is bigger than 0 or minus 4. Okay, so I hope I give you a good understanding if you have forget. And then lastly, k should be smaller than 0.49. For our Excel example, we actually calculated if you sub in a k smaller than 0.39, your outcome is a positive value which is larger than 0. Okay, I hope you understand. So our k is a smaller value than 0.49, so we are going in this direction. Okay, nonetheless, we'll draw a line across the 0. So k, whatever k that is bigger than 0, we are taking it. Okay, so 0, k, right? So whatever k that is bigger than 0, we want. Okay, this is our criterion, our Ralph-Horowitz criterion. And then whatever values that that can satisfy all of these 4 conditions is actually 0.49, because it touches, you see, it touches all the four number line itself. So this is the portion that we want, and so k should be smaller than 0.49 while it is bigger than 0. So you can have 0.11, 0.12, all the way up to 0.48 also can. Okay, so nonetheless you can also have 0.0001, whatever, and I think you understand. So we have found k that is larger than so we have found this range. So nonetheless, you also have to write down all the criterion stating that all coefficients are positive, and then this stuff. Hey, sorry, this is. So for Ivan right now, so nonetheless for part 4, this question. So far I think you still remember we are doing this question. Okay, so the coefficients are all positive, and then k is this value which is larger than 0, and so we satisfy, and then it should do the trick. Okay, it should do the trick. So this summarizes what we have understand for all Ralph-Horowitz, how we do it and everything. And nonetheless, you can see I actually took 20 few minutes to actually do out this few questions. Yeah, do out these 5 questions worth 12 marks using 20 minutes. One question is about 30 minutes. So how about, so I need to use 8 minutes to solve the 8 marks question, right? Which is like, so I have, in this case, I have to really work on how to, solve this all of them in a very quick time, so that I can actually save time. But nonetheless, let's do a summary. Okay, we actually talk about Ralph-Horowitz intro, and then we talk about what the rules. If you remember my rules, the simple first order and second order, all coefficients are positive. If it's third order, you have one more rule, which is A1, A2, should be larger than A0 and A3. And then if it's a higher order system, all coefficients are positive the same. So all coefficients are positive must be applied to all systems. And then elements of the first column in the Ralph array are all positive. When you plot in your arrays, make sure it's positive. And then and then we also talk about we rigorously talk about how to draw the timeline, trying to understand what is the k range that we are needed, as the k value within this range, if you sub in your equation, you'll let it be stable. Okay, and then we also talk about a trick question over here. If there is no order, okay, if there is no, as you can see, second order is as you can see, this is the third order, there is no second order, and then suddenly it becomes first order, and then, so in this case, you need to also prove why this is not stable. So nonetheless, Also, you have to remember the coefficient. I mean, sorry, you have to remember the criterion. It should be in your head, resonating. So with this, I believe I have cleared all the summary for all the raw reads. Nonetheless, you should go and watch the series from Brian Douglas, and then I've already posted inside the playlist already, so you can just follow by the rest of the videos, and then because the rest of the videos will talk about what are the special cases and what are the cheat codes. So I'll see you in the next lesson for root locus. So goodbye.